Hello everyone, welcome to our home, the Earth, Part 2. By the end of the lesson, let's be able to describe the Earth's movements and explain how the Earth's axis and revolution cause the four seasons. The Earth's movements. The Earth has two movements, rotation and revolution. But before we learn about these movements, we must first learn about the Earth's axis. The Earth's axis tilts at the angle of 23.5 degrees from the perpendicular of its plane of orbit, which is also known as the orbital plane. In other words, the tilt of the Earth's axis can also be expressed as 66.5 degrees from its orbital plane. What do we mean? Consider this diagram. Here, we have the Earth being illuminated by the sun, showing the day and the night. And here, we have the Earth's axis in June that tilts towards the sun, along with the orbital plane. Are you able to identify the 23.5 degrees and 66.5 degrees angles of tilt? Rotation of the Earth. The Earth rotates on its own axis from the west to the east and takes 24 hours to complete one rotation. It is this movement that causes us to experience daylight and darkness. Do you know that the planet Venus takes 243 Earth days to complete one rotation? So how many Earth months is one Venus day? Revolution of the Earth. The Earth revolves around the Sun along a path known as an orbit and takes 365 and a quarter days to complete one revolution around the Sun. As a common calendar only has 365 days, the quarter day is added to the month of February every 4 years. This became known as the leap year. Do you know that the planet Venus takes 225 days to complete one revolution? This also means that Venus has a shorter revolution than its rotation. In other words, a shorter year than its day. Here, we have an illustration of the orbits of the planets in our solar system as they revolve around the Sun. Can you name them all? The seasons. So how do the Earth's revolution and the tilt of its axis lead to the seasons? Again, we have the Earth and the Sun. The part of the Earth facing the Sun will experience daylight, while the other side will experience darkness. And we know that the Earth rotates around its own axis at 23.5 degrees to the perpendicular of its orbital plane. Consider a location along latitude X. Does it receive more daylight or darkness? Is it experiencing summer or winter? Consider again a place which lies along the equator. Does it receive more daylight or darkness? Will it experience seasons? Let's try this again. Here, we have the Earth and the Sun in December as the axis tilts away from the Sun. Consider again a location along latitude X. Does it receive more daylight or darkness in December? Is it experiencing summer or winter? And the place that lies along the equator, does it receive more daylight or darkness? The solstices. On June 21st, the midday sun shines directly overhead at the Tropic of Cancer. This day marks the beginning of summer and is called the summer solstice. Study the angle of the sun's rays on the Tropic of Cancer. The sun is said to be directly above the Tropic of Cancer as the angle of the sun's rays on the surface of the Earth is 90 degrees. The day this happens thus marks the summer solstice. Conversely, the sun shines directly overhead at the Tropic of Capricorn on December 22nd. This day marks the beginning of winter and is called the winter solstice. Study the angle of the sun's rays on the Tropic of Capricorn. The sun is said to be directly above the Tropic of Capricorn as the angle of the sun's rays on the surface of the Earth is 90 degrees. The day this happens is known as the winter solstice. Due to the movements of the Earth, and the tilt of the axis, there are 2 days in the year when all places all over the world experience equal day and night. These 2 days are known as the spring equinox and the autumn equinox. Question: is the axis of the Earth tilted towards or away from the Sun during the equinoxes, or is it neither? In closing, we should be aware that life can exist on the Earth because it possesses suitable conditions for life, which in part is because of the Earth's movements. Question: do you think that the conditions will always be this suitable? How can we ensure that they remain so? I would like you to refer to your textbook, page 10, for more information. Alrighty then, see you next time.